This is the first video of a three-part videos series on spurious emissions. In this first part, we go over an explanation what spurious emissions are and the FCC rules about that. In the second video, I'm gonna talk about and actually show you how to measure spurious emissions with a spectrum analyzer, the Siglent spectrum analyzer. And then in the third video, we're gonna go test a whole bunch of radios that I have access to. So let's go ahead and talk about spurious emissions. First of all, I want to make it clear that I am a licensed amateur radio operator, and the key word here is amateur. So right here is the definition on amateur, so keep that in mind as I'm going over this video or any other videos about the amateur radio. So what are spurious emissions? An emission is a signal that we transmit. So for example, right here, this is our signal that we want to transmit at 146 megahertz, so in the 2 meter band. Spurious emissions are signals that our transceiver transmits outside of our band where we transmit. Often these signals are harmonics. So for example, the 439 megahertz, this signal here would be the third harmonic. So the first harmonic is always the fundamental frequency that you actually transmit. The first harmonic is then your frequency times 2 about, and the third your frequency times 3. And the key part here is that we do not want any other frequencies, any other signals outside of our intended signals to be transmitted. The reason for that is that we interfere other users in those frequency ranges. And if our signal is even strong enough, you can clearly hear our communication on these other frequencies. And that's definitely not desired, because we don't know, as we transmit on 2 meter, we don't listen to all the other frequencies and see how we affect them and the users there. So as mentioned, right here, this is the fundamental, and these peaks are our spurious emissions. So in this example, we can see that there is 93.93 decibel between the fundamental, so this signal here, and our third harmonic. And this can be gained from reading the amplitudes of these two signals. So our fundamental is at 44.45 decibel dBm, and our third harmonic is at negative 9.48 dBm. And so you just add the 44 plus the 9 together to get the full difference between these 2 points, since 0 dB is around here. So right here we can also calculate these decibels here, which decibel is just a difference in power, and decibel dBm is it's a reference to 1 milliwatt. So with that, with the 44.45 dBm, we can calculate the actual wattage of our signal. So we can figure out how much wattage our fundamental is, and also how much wattage our spurious emissions are transmitted at. And if you remember the table of the dBms. So here's a few dBm samples. 10 dBm, 0 dBm is our 1 milliwatt. So 10 is 10 milliwatts, 20 is 100 milliwatts, 30 is 1 watts, and so on. So if we look at this here in the watts, now we can see that our fundamental is in 27.48 watts being transmitted, and our third harmonic is 112 microwatts. Again, what do those numbers mean? Is that, are those harmonics too strong or not too strong? And that's what we look into our FCC rules here in the States. So right here, the rule 97.307C tells us that all spurious emissions from a station transmitter must be reduced to the greatest extent practical. If any spurious emission, including chassis or power line radiation, causes harmful interference to the reception of another radio station, the licensee of the interfering amateur station is required to take steps to eliminate the interference in accordance with good engineering practice. So right here it says that we as the operator are responsible to mitigate those spurious emissions. But it's still fairly vague to us what it means. So if we go back and look at our measurements here, we still don't know if those harmonics cause any issues or not. Because of that, the FCC has given us a couple more rules that help us out with this. So the rule 97.307D talks about the HF frequency primarily. So for all newer transmitter installed after January 1st, the mean power of any spurious emissions from a station transmitter or external RF power amplifier transmitting on a frequency below 30 MHz must be at least 43 decimal below the mean power of the fundamental emissions. So if we look back at our chart, we pick the one with the decibels. So right here we see that our spurious emission would be 53 decimal below the fundamental. So if it was in HF, then we are in compliance right here. Then they have some extra things for older stations as well. So let's look at the rules just in different words here. So if you are below 30 MHz and installed after January 1st, 2003, then you have to be 43 decibel below the fundamental. So here are some examples what that means. So if you are transmitting legal limit, your fundamental, your harmonics or any other signals besides the fundamental might go up to 75 milliwatts. At 100 it's still 5 microwatts, and then at 5 watts it's 251 microwatts, and 1 watt is 50 microwatts. If you're fortunate enough to be working with a station that's installed before 2003, then it's a bit more lenient and slightly more complicated. So for any fundamental, so for your signals with 500 watts, if you run 500 watts or more, then it cannot be more than 500 milliwatts. If you run 5 watts or more, so 5 watts to 500 watts, then it has to be 40 decimal below the fundamental. So again, the So at 5 watts that would be 50 microwatts. And for a station less than 5 watts, you would have to be 30 dB below the fundamental. So at 1 watt that would be 1 milliwatt. The next rule talks about the higher frequencies. So that's 30 Hertz to 225 megahertz. So the two bands that really fit into it is the 2 meter band and the 1.25 meter band. So for those ones, if you transmit, it should be 60 dB or lower. For a transmitter having a mean power of 25 watts or less, then it becomes more restrictive. It has to be not exceed 25 microwatts and must be at least 40 dB below the mean power of fundamental emissions, but need not to be reduced below 10 microwatts. So what that really means is right here, so if you are between 30 and 225 and run more than 25 watts, then you need to be 60 dB below the fundamental. So that would be at 100 watt, that would mean 100 microwatts, and 50 watts it would mean 50 microwatts. If you run 25 watts or less, then for any signal that's 250 milliwatts or more, your spurious emission cannot be more than 25 microwatts. And for any signal less than the 250 milliwatts, it needs to be 40 dB below the fundamental or 10 microwatts. So once it's 10 microwatts, you don't below 10 microwatts, you don't have to worry about it anymore. So the other thing that I wanted to mention is the interesting part of how the bands are set up. And often the bands are set up so the harmonics are of that band are in another ham band. So if you look, for example, at 160, our second harmonic is in the 80 meter band, and then part of our third harmonic is in the 40 meter band. Same again with 80 meters. Our first harmonic is our second harmonic is in the 40 meter band, and the fourth harmonic is partially again into the 20 meter band. Same for 40 meter, where it's in 20 meter and a little bit of 15 and 10, and 20 meter is in the 10 meter band. If you look at the 2 meter band, there the third harmonic is right into the 70 centimeter band. So that's actually kind of an interesting setup, because that way if the amateur radio operator is interfering with somebody, it's basically interfering with its peer group. And the FCC is really relying on the amateur radio operators themselves to kind of educate and partially also control themselves on that. At least that's how I perceive it in the past here. Another thing that I wanted to mention is that there is no Part 97 certification for radios from the FCC. So none of the amateur radios are actually licensed for amateur radio usage. Instead, it's the amateur radio operator that has to ensure that the radio is compliant with these Rule 97 compliant. So we need to ensure that these radios meet the emission standards as well as some of the other standards that are required for transmitting on the radio band. And that's where the interesting part comes. You kind of have to do the measurements yourself, or be able to trust the company that from whom you purchase the radio, that it's compliant, because ultimately you as the ham radio operator are responsible for the emissions that you cause on the airwaves. So what that means is even the big radio manufacturer, the big three, Yaesu, Kenwood and ICOM, they are not really licensed for the amateur radio usage. Instead, they just create quality transceivers and want to ensure themselves that it meets all of the requirements, because otherwise nobody would buy those expensive radios. On the other hand, there are devices out there that do not meet those criteria, and even though you could use that, you actually violate the FCC rules under 97, and that is really ultimately you as the operator is responsible for the proper operation, and you as the licensed operator is responsible if you transmit with a device that does not meet these rules. And that's where it gets hard, because if you buy one of those devices where you cannot trust whether or not they have spurious emissions, and you don't have the ability to measure that, then you really transmit in the blind without knowing it. And according to any kind of a law in most countries, probably all countries, is unknowingness really doesn't protect you from the law. There's always the requirement that you need to meet the law even if you don't know it. So with that, we're gonna stop the first part. So in the second part, which will be much more interesting, I'm going to show you on the spectrum analyzer how to measure the spurious emissions, and so you can determine whether or not your device is in compliance.